Well, I'm Rex Smiley, as Abby said, and I'm a scientist with the clinical development team at Boehringer Ingelheim Animal Health, based in St. Joseph, Missouri. And I'm responsible for running some of the swine studies that are required for licensure with the USDA Center for Veterinary Biologics. As Mark just talked about all the background of the product and influenza in general, I'm going to focus on the two studies that we ran, two efficacy studies that we're going to talk about throughout this presentation. As I mentioned, from working for an animal health company, we're under numerous federal and global guidelines, rules, and regulations when conducting these studies. To license a study in the U.S., my customer is the USDA, Center for Veterinary Biologics. And sometimes what the government requires of us and what you folks in the field or our colleagues in sales and marketing, what you want to get from a study doesn't always align with what the USDA wants. So as we look through the study design and then the results of these efficacy studies, feel free to ask the question why we did something the way we did. But keep in mind, a lot of times the answer is because that's what the USDA wanted. We conducted two separate studies with very similar study designs, each intended to test a different fraction of the vaccine. Both studies utilized the lyophilized bivalent vaccine containing both H1N1 and H3N2, compared against pigs that were given saline as a control. Pigs needed to be seronegative for influenza A virus, so we had to source dams from a farm that had no history of influenza infection or vaccination, and where they tested negative to both H1N1 and H3N2 antibodies. We brought dams into a biosafety level 2 facility about 3 to 4 weeks prior to farrowing so that we could vaccinate the pigs right on the dam. When the dams were brought in, they were randomized to room, and then treatment was randomized to room so that litters receiving the vaccine couldn't be accidentally exposed to the litters receiving the control. After the last pig was born at farrowing, all the pigs were vaccinated, and they were 1 to 5 days of age at vaccination. So here's our timeline, starting with that intranasal vaccination at 1 to 5 days of age. At approximately 3 weeks of age, the pigs were weaned and then commingled into one room so that treatment groups could be represented as equally as possible within a pen, and litter mates would be housed together when possible. At about 4 weeks of age, the pigs were challenged intratracheally with 2 mils of live vaccine virus. And then they were followed for a 5-day challenge period where we looked at clinical signs consistent with influenza. Also during that challenge phase, nasal swabs were taken from each pig on each day for detection of viable virus by virus isolation. 5 days after the challenge, pigs were euthanized, and then the lungs were looked at and scores the percentage of lung with lesions consistent with influenza. As a recap of the two studies, here's sort of the side-by-side with the details. For the study testing the H1N1 fraction, pigs were between 1 and 5 days of age at vaccination, and for the study testing the H3N2 fraction, pigs were 1 to 4 days of age at vaccination. So here we can see with the number of pigs that we ended up in each study. Like I said, they had to be randomized before they farrowed, so once they farrowed, we were kind of stuck with the numbers that we got from those dams. Pigs from both studies were weaned and moved to the challenge phase pens at 23 days post-vaccination. So the H1N1 efficacy study challenged 25 days post-vaccination with a heterologous H1N2 virus. This tends to be a point of confusion. We used an H1N2 virus to test the efficacy of the H1N1 fraction of the vaccine. During our initial discussions with the USDA, this was seen as a more rigorous test of the H1N1 fraction of the vaccine, since theoretically, the H1N2 would be more heterologous than any H1N1 vaccine or H1N1 challenge strain. The H3N2 portion of the study was challenged with a heterologous H3N2 virus. As previously mentioned, the challenge phase for both studies was 5 days long, ending with euthanasia, necropsy, and then lung evaluation. So now that we've kind of talked about the design of the two studies and how they worked, let's look at the results. The USDA has required us to demonstrate a significant reduction in lung lesions as the primary outcome parameter for efficacy. In both studies, we can see the mean and median lung lesions were significantly reduced in the vaccinates when compared to the controls. Actually, over 75% reduction in both studies. As we start to look at the distributions of lung lesion data, as with most experiments, there's going to be some outliers in the data. But it's interesting to note that in both studies, the range for lung lesions that we see in the control animals extends well beyond what we see in the vaccinated animals. Lastly, as can be seen below each graph, both studies were very statistically significant, with greater than 99% confidence in the difference in lung lesions between the vaccine and the control groups. The next primary parameter that we looked at was the reduction of clinical signs. The USDA considered a pig affected with a clinical sign if it showed that sign at least twice during the 5-day challenge phase of the study. So using that criteria, the vaccine significantly reduced the occurrence of clinical signs, again, in both studies. I also wanted to show you the clinical sign data as the raw data. This table is a list of the control pigs that we had in the study that were challenged with H1N2. Each line is a pig, and then each column is a day post-challenge, 1, 2, 3, 4, 5. The clinical sign or signs that were recorded for each pig are color-coded for sneezing, cough, ocular or nasal discharge, increased respiration, or abnormal behavior, which was a measure of depression or lethargy. So here's the same data for the vaccinates. And I know it's hard to see some of that, but the point is to see there was quite a few less in the vaccinates versus the controls. And here we have the same data for the H3N2 efficacy study. In both studies, if a vaccinated pig had a clinical observation, it was typically it was an isolated case. And if it was observed in the control animals, it typically had more than one during that 5-day challenge phase where we did the clinical observations. The final parameter, which may be one of the most important from an epidemiological control strategy, is reduction of shedding. These two figures show the percentage of pigs in each treatment group that had a positive virus isolation result from the nasal swabs collected on each day of the study from each pig. The first figure is the H1N2 challenge, and the second, of course, is the H3N2. The blue represents the control pigs, and sort of the gold color there represents the level of vaccinates. By either logistic regression or Fisher's exact test, the number of pigs shedding virus was significantly lower for the vaccine on every single day of sampling for both studies, H1N2 and H3N2. Again, kind of breaking that down by the raw data, you can see it's a drastic difference in the number of positive samples from shedding. On the left, controls, and the right, the vaccinates. And here's the same data for the H3N2 study. So looking at this, I have two key messages that I want you to think about. The first one, the results here are detecting viable live virus by virus isolation, which is a qualitative or sort of binomial yes or no for live virus. A PCR assay would have detected genetic material whether it was viable or not. The challenge material was placed directly into the trachea of each pig, and we know that they all got a good virulent challenge. And what's amazing, in over half of the vaccinated pigs, no shedding was able to be detected at all. The second major point that I want you to think about is that pigs didn't receive the pigs that did not receive the vaccine were constantly shedding to the pigs that were vaccinated. Because as I mentioned earlier, at the challenge phase, they were commingled all together. So in the real world, all the pigs in your farrowing barn, farrowing house would have been vaccinated. You wouldn't have these additional control pigs. And they wouldn't be experiencing that constant viral pressure from the non-vaccinated pigs. I think if all these pigs would have been vaccinated, we may not have seen much shedding at all. And I think, that's pretty remarkable when you look at a control strategy for influenza. So here are sort of the conclusions from the study reports that we filed with the USDA and with which the USDA agreed. When newborn pigs were vaccinated with Ingelvac Provenza and exposed to virulent heterologous H1N2 or H3N2 virus, we saw a significant reduction in lung lesions 5 days post-challenge, a significant reduction in observance of clinical signs 5 days during the 5-day challenge period, and a significant reduction in the number of pigs shedding virus during the 5-day challenge phase. As Dr. Rosner mentioned earlier in his presentation, you may have heard about the USDA's initiative to streamline the licensing process, moving away from the historic label claims like prevention or aid in prevention or reduction or aid in reduction. As part of this move to a single-tier label claim, the Provenza vaccine was one of the first to be granted a claim, and the label reads, "This product has been shown to be effective for the vaccination of healthy pigs 1 day of age or older against influenza viruses H1N2 and H3N2. And then you're directed to a website where you can see all the data that I just went over today is published in an ISS on the USDA website. With that, I would like to acknowledge my co-authors for the study, Mark Eichmeyer, who spoke just before I did, Wes Johnson and Dr. Brian Fergan, Dr. Troy Kaiser as a primary scientist that I helped on conducting these studies, as well as some of our marketing colleagues, Dr. Krista Goodell and Sarah Jorgensen. Both of these studies were conducted at Biosafety Level 2 facilities owned by VRI in Cambridge, Iowa. So I definitely want to thank Drs. Lyle Kessel and Dr. Ryan Salzman and the entire team at VRI. With that, I thank you for your time, and if you have any questions, I'd be happy to try to answer them for you. If not, you can catch me outside or Dr. Goodell at any time.
We have time for a couple questions, so go ahead and I'll see if the mic's on there.
Yeah, Kim Segales from Spain. Thank you very much for your nice presentation. As far as I understood, you challenged animals which were seronegative, right? I mean, they were seronegative.
Right.
So do you think, maybe you did already an experiment with colostrum-fed animals showing antibodies?
Yeah, so that's a good question. Like I said, for these two studies, we had to do it in seronegative animals because that's what the USDA required. We did have done some additional studies in seropositive animals, and in fact, the next presentation is going to discuss just that, on breaking through that maternal antibody in seropositive animals.
Okay, sorry for discovering your next presentation, by the way. And just a very last question, because at least from a kind of European perspective, I would have expected your vaccine contain also H1N2. I know that you have shown a kind of cross-protection, but anyway, in beforehand, probably it was not expectable to have such a good result. So why did you skip the H1N2 virus from the very beginning? Thank you.
Yeah. No, that's also a very good question. I know that they looked at several different things in the early research phases of this. I think you kind of answered your question. I think that they thought that the H1N1 that's included in the vaccine would be cross-protective against the H1N2. And so from that, from the selection phase in the very beginning, I'm not sure on those details, but Dr. Goodell may be able to help you answer that if you want to try to catch her after this. Any other questions?
I wonder if you could comment on the challenge model that you used. Challenge models are difficult because of the tremendous difference between what is seen epidemiologically in the field versus an experimental challenge model. But could you comment on how the criteria you used to develop this particular model, and maybe some comment on how negotiations with USDA go on picking a specific model?
Yeah, I think we could have an all-day discussion on how we design and do a challenge model study and how we just end up on a certain challenge model. I think, since our primary parameter for this is lung lesions, that was our focus in our challenge model development. So taking certain isolates and testing different methods in challenge model studies are kind of how we came up with the intertracheal model to get the lung lesions we're looking for in control animals. So that's the first step, right? You want to get high enough lung lesions in those controls to sort of stimulate something you might see in the field from a constant exposure. And so that's kind of in a nutshell how that's done. There's several smaller research studies until we get to a point where that challenge model is what we want.
And I'll add a little bit to Rex's comment there. At Boehringer, we try to use things as globally as possible. So if there's an opportunity for us to use data that's generated in the U.S. in support of a European registration, we'd like to do that. There is an EU pharmacopoeia guideline that states an intertracheal challenge for this. So that's the main reason why we went the IT route.
Thank you, Mark.
Thank you. Can you say something about the safety in another mammalian and non-mammalian species with your vaccine? That's the first question. And the second, your vaccine strains have the possibility of genetic drift and genetic shift?
Those are both very good questions. So to answer your first question, we did conduct non-target animal safety studies. That was also required as part of this licensure for the USDA. So the non-target safety studies that we looked at were in rats, chickens, and then ferrets. And ferrets are kind of the universal human model, if you will, to look at the zoonotic potential for anything. So we did conduct a study with that, and be happy to talk to you a little bit more, after the presentation here on what we saw in that study. Also, Dr. Troy Kaiser, who's in the audience, did a presentation on that a couple days ago for the non-target. So hopefully that'll answer your first question. And then the second question, talking about genetic drift. I know that we are in the process of doing some additional studies in the field, looking at that. And I don't know if maybe, Mark, would you be able to answer that a little better? I know we're looking at potential studies and have done some.
Yeah, and I guess with that concern, you have to look at the level of biological fitness that is really in the environment. And so we've looked at not only co-infection models, but also just back passage models. And with the back passage, in other words, where we took the vaccine and stuck it in the animals and tried to re-isolate it and give it back on a series of times, we actually, the only difference we saw in the whole genome was actually a further truncation in the NS1 gene segment. So that showed that it was stable and there was no reversion to virulence. And then even in a co-infection model, if you were to look at that, the possibility of picking up that NS1 gene segment to make a viable virus, one would only result in a virus that had already previously existed in the environment, so there would be no new introduction of nucleic acid into the field, and you would see nothing more than what had already previously existed in the field.
Sorry, did you make back passages of these viruses? How many back passages did you make?
5.
5? And what about the results? Very stable? It means the truncation maintains after the 5 passages? Okay.
I couldn't hear what he said there.
The NS1 truncation increased a little bit, but it was overall stable.
One more question. So the major concern about the inactivated flu vaccine is the duration of immunity. So we are not satisfied the short, normally 2 months for the duration of immunity. How about your new vaccine for the DOI? If you have, or if you don't, what's your expectation?
Yeah, and that's a great question. We're currently working on the duration of immunity studies for this. This study was just licensed recently and launched here at this meeting. We are currently working on models to evaluate the duration of immunity, looking at those primary parameters that the USDA set with lung lesions, clinical observations, and virus shedding.
Thank you. Assume this is the GMO, right? It's the NS1 gene deletion. Do you have the Federal Register risk assessment data available? Okay.
Yes, that data is available on the USDA website. Well, thank you, everybody. Appreciate it.